Good day, everyone. We are now on our fifth and fifth week of discussion for Chemistry 2. And now our topic is about nature of solutions. Okay, what are the nature of solutions? So for today, our objectives or goals for this week pala is to describe the properties of solutions, classify solutions, and give examples of each, and measure the concentrations of solutions in terms of ppm, percent by mass, percent by volume, mole fraction, molarity, and molality, and also distinguish saturated and saturated and supersaturated solutions, dilute and concentration solutions, and explain concentration of solution in terms of molarity, molality, and mole fractions. But for this week, or for this lesson, we'll just deal with the nature of solution. So nature of solutions. So solutions are homogeneous mixtures and they have a uniform composition all throughout. As we have discussed this one from our first week of discussion in chemistry 1, okay, we discussed about homogeneous mixtures and heterogeneous mixtures. So we are able to differentiate both homogeneous mixtures and the heterogeneous. And for example, a spoonful of juice taken from a jug full of juice will taste the same as any sample from any part of that same jug full of juice. So whether that particular mixture is already mixed up, so you can no longer separate the powdered juice into the water or from the water because it's now becoming a homogeneous mixture or a solution. So what consists or what composes the solution? So we all have know one first a solute. Okay, it's the substance that dissolves in the solution, and second is the solvent. Okay, the solvent is the substance in which the solute dissolves. So in our example, we have here, I think it's a methylene blue. Okay, it's the one which is being dissolved in water. So we have the water, so as the solvent. So as we combine that two substances, they become a solution or it becomes a solution. And if you look at the solution, you can no longer separate the two because it's becoming a mixture. You also have a solution may be one or more solutes dissolved in a given solvent. So we can use different solutes in a solvent. Okay, it depends on the nature of the particular solution that you're making. So for example, a cup of cappuccino is a combination of espresso coffee mixed with frothed hot milk or cream, and often flavored with cinnamon. When two or more liquids are mixed to make a solution, it's sometimes difficult to tell the solute from the solvent. So when you mix such that one, as an example, the cappuccino with espresso coffee mixed with hot milk, so you can no longer know which of them or which of the top solutes are being combined to a particular solvent. So as a rule, however, the components is greater amount in the solvent or in a solution, there should be a greater amount of the solvent than the solute. Okay, the one who is which is lesser is the solute. So for example, if 10 ml of vinegar is added to 15 ml of water, vinegar is the solute which is 10 ml or lesser than the water which is the 15 ml. So to be able to dissolve something, it should be that the solvent should be lesser, or the solvent should be the in greater amount. Sorry. So how we have different terms to know when we talk about solution or nature of solution. So we have first we have soluble. So a soluble substance is the a substance that dissolves in another substance. So we have an example: salt and sugar are soluble in water. So it has the ability to dissolve in water. Also insoluble. So when we in another substance pala, hindi lang pala water. So let's have insoluble. You have the substance that does not dissolve in another substance. So if that substance is has a hard time dissolving, then that is insoluble. So we also have miscible. So right now we're talking about liquids. So when liquids are completely soluble in each other, then that is called miscible. So when liquid plus another liquid, or shall we say in a solution, meron tayong dalawang liquid added together, form a solution, and they are completely soluble, then that is miscible. We also have immiscible. So when liquids which are not soluble in each other, so when you add two liquids, but they will not mix with each other, then that is what called as immiscible. So in our example, we have water and oil. When you mix the water and oil, the oil will not mix with water. So because of its different polarities, or because it can't dissolve on that nature of solution. So what about aqueous solution? So when you say aqueous solution, it's a solution in which the mostly used solvent is the water. So kaya tawag siyang aqueous solution. So because water can dissolve many substances, so it is called the universal solvent. So most of our solutions are water, or mostly the solvent used is water. So we call that one as an aqueous solution. So we also have a term called electrolytes. So when you're drinking Gatorade or mga drinks that are for uh, okay, when a substance that dissolves in water to form a solution that conducts electric current, they are actually called as electrolytes. So just like what I have said, so when you're drinking mga sports drink, okay, for energy, for you to gain energy though, so that's actually, it's because it has presence of an electrolyte. So it can conduct electric currents, so such as sodium chloride solution. So it's an electrolyte. So when you do experiment with uh, conduction, so pwede siya maka-conduct of electric currents. So we also have non-electrolytes. So from the opposite of electrolyte, is the opposite of electrolyte. So it's still a substance that dissolves in water to give a solution that does not conduct electric current. So sugar solution is a non-electrolyte. So it cannot conduct electricity or electric currents. So the term used when we combine, or even there will be a combination of solute particles and solvent particles, is what we call as solvation. So meaning it's the process of, or the combination of solutes and solvent particles. So one example of solvation is hydration. So it's a process used to describe the combination of solute particles and specifically with water particles. So solute plus water particles. So it's the process is called as hydration. So what are the different types of solutions? So solvents other than water are oftentimes used to dissolve other solids. So it's not only water to be used as solvents, but there are a lot of different types of solution that solvents are, it's not only with water. So we have, okay, for example, we have different types of solutions. So we have gaseous solutions, we also have liquid solutions, and solid solutions. So we have, for gaseous solutions, we have air as an example, and you can see that the solute for air is oxygen and other gases, while the solvent is nitrogen. So for liquid solutions, we also have we can dissolve gas in liquid. We have liquid in liquid or solid in liquid. So examples are soda water, antifreeze, and seawater. So how about the solid and solvent used for different types of liquid solutions. We have carbon dioxide and water combination for gas in liquid, and we have ethylene glycol, and the solvent is water for liquid in liquid interaction for solution. So we also have sodium chloride and water in the nature wherein meron tayong solid and liquid na solution. Okay, how about solid solution? So can we still mix two particles and then mahimo mo siya homogeneous mixture if solid solution? So we can have liquid in solid. So ang liquid is dissolved in a solid. So dental amalgam. So we have the mercury and the solvent is silver. So we also have solid in solid. So we have steel. So what's the composition of steel? It's made up of carbon and iron mixed together. And gas in solid, we have charcoal filter. So we have a composition based on the poisonous gases and carbon. So that's examples of different types of solutions. And okay, so okay, I hope you're still following. So we also have solubility. So the solubility is a term that you use to describe the maximum amount of solute. So when you're talking about the maximum amount, that's the basis of uh, the ability of that given solute to the given amount of solvent that it can be solved at a given temperature to give a stable solution. So meron tayong binibase na temperature and syempre the amount of the solute to a particular amount of solvent. So a stable solution is a solution at a dynamic equilibrium. Okay, the rate of the solution is equal to the rate of crystallization. So when we talk about the heat absorption and heat release, actually mo na ni siya na discussion when still there is an equilibrium to the rate of the solution and the rate of crystallization as heat release or heat absorbed. Okay, dyan mo makikita yung solubility na naka-effect for its crystallization or the solution. So, what are the different types of solution based on the amount of solute dissolved? So, it means that okay, we will base the solution based on the amount of the solute or the amount meaning how big or how small or the amount mismo, the amount of the solute is being dissolved on a solvent. So we have unsaturated, saturated, and supersaturated. So we have the unsaturated is when we have a solute, but its solute is less, we have a less solute particles than the maximum amount of the solvent that can dissolve at given term. So we have a solvent, but we just put less amount of a solute. Okay, how about saturated? So when we have saturated, a solution that contains the maximum amount of solute at a given solvent that can dissolve at a given temperature. So we have this as our stable solution, meaning it's the normal one. So tama ang concentration. So we also have supersaturated, a solution that contains more particles than the solvent can hold. So meaning in a given amount of a solvent, okay, is greater, okay, meaning wala siya ni follow sa solution na kailangan mas lesser pa ang solute. So meaning it has a greater amount of the solute than the solvent. So let us take a look at the video so that you will learn something and you know the differences between the three types of solution based on its saturation or the amount of solute.
Solutions like sugar in water has two components. The two components of solutions are solute and solvent. Solute is a substance that dissolves in solution. It is usually present in small amounts. In this mixture, the solute is sugar because sugar dissolves in solution and is usually present in small amounts. Now, let's talk about the solvent. Solvent is a substance that dissolves a solute. It is usually present in greater amount. The solvent in this solution is water because water dissolves sugar and is usually present in greater amounts. Between solute and solvent, we will focus on the solute. The ability of solute to dissolve in solvent is what we call solubility. Solubility is a maximum amount of solute that can dissolve in a given amount of solvent at a certain temperature. The amount of dissolved solute produces three types of solutions. Here's an experiment about the three types of solutions based on the amount of dissolved solute in solvent. Unsaturated solution is a solution that contains less solute than the maximum amount the solvent can dissolve at a given temperature. Its color is lighter than saturated and supersaturated solutions. Saturated solutions is a solution that contains the maximum amount of solute dissolved by a given amount of solvent. The color of saturated solution is intermediate between unsaturated and supersaturated solutions. Supersaturated solution is a solution that contains more solute than the maximum amount the solvent can dissolve at a given temperature. Its color is darker than unsaturated and saturated solutions. It has an excess solute or sugar which can no longer dissolve. Let us sum up. The three types of solutions are unsaturated, saturated, and supersaturated solutions. Unsaturated solution is a solution that contains less solute than the maximum amount the solvent can dissolve at a given temperature. Saturated solutions is a solution that contains the maximum amount of solute dissolved by a given amount of solvent. Supersaturated solution is a solution that contains more solute than the maximum amount the solvent can dissolve at a given temperature. The color of unsaturated solution is lighter than saturated and supersaturated solutions. The color of saturated solution, on the other hand, is intermediate between unsaturated and supersaturated solutions, while the color of supersaturated solution is darker than unsaturated and saturated.
Yes, what you have learned from the video. So unsaturated, saturated, and supersaturated differs in the amount of solute that is present in the solution. So more solute dissolves in unsaturated, no more solute dissolves in saturated because there is an exact amount of water to water amount, or the solvent amount to a given solute. So we also have supersaturated, which is more of the viscosity, so mas viscous, and crystals may grow from supersaturated. So that ends our discussion for the nature of solution, and we continue with our discussion for the factors which affects solubility. So what are these? So we have the nature of solute and solvent, and also temperature and pressure. So with the nature of solute and solvent, it's more on the the saying likes dissolves like, when a polar substance can dissolve to a polar solvent. And we also have non-polar substance can dissolve better in a non-polar solvent. So that is the rules for polarity. So for temperature, so if you've learned from our discussions from the ideal gas laws, the properties of solids and liquids. So we actually talked about what is the effect of temperature to the different types of, or the different phases of matter. So we have four gases and liquids. An increase in temperature will decrease in solubility. So meaning, increase in temperature, meaning pag higher ang temperature, then it is indirectly proportional to the solubility. So we also have most solids in liquids are an increase in temperature will also increase in solubility. So for solid in liquid, when there is an increase in temperature, then it's directly proportional to its solubility. And for pressure, so for gases and liquids, so increase in pressure rather, will increase in solubility, and gases can dissolve in liquids by, first, when you're lowering the temperature, and you are also increasing the pressure. So it can high on pressure, so mas mag-dissolve siya, but if it's also low on temperature, then it can also dissolve in liquid. So solubility of solids in liquids or liquids in liquids is not greatly affected by pressure. So with that that uh, specific na combination, then it cannot affect the pressure can greatly affect the solution. So what are the different factors affecting the rate of the solution? So when we have particle size, agitating or stirring, and temperature. So this can affect the rate, meaning how fast or how slow the rate of reaction, or the time of the dissolution. So we have the concentration and dilute. So concentration, meaning let's review first for the particle size, meaning if it's greater in particle size or is big, then syempre the rate of the solution will be slower. Pag gamay or small, then the rate of the solution will be faster. So stirring can actually hasten the reaction, or it can be fast or slow. Kung fast ang steering, then fast then ang rate of reaction. But if it's slow ang steering, then it's becoming slower ang the solution. Okay, with temperature, the higher temperature it is, then the solution will be fast. And then if it's low temperature, then the rate of the solution will be also slower. Okay, concentration and dilute. So when you say concentration, it's like saying Okay, a term used to designate the amount of this of solute dissolved in a given amount of solvent or solution. So more on, it has higher or the designate amount of solute is should be in that exact or given amount of solvent. So, meron siyang reference to how much or the amount will be put in a solvent para siya makagawa ng solution. So, for dilute, is the term dilute is normally associated when you use to denote the product of dilution process. So, what is dilution? It's the process of preparing a less concentrated one by adding solvent. So, para mag-dilute ang isa ka solution, you will be adding more solvent, okay, para mag-less ang iyang concentration. So meaning, okay, in our term is like we call it lasaw. So you add more solvent to make the concentration lesser. So that ends our discussion for the nature and types of solutions. So I hope you've learned something from this, and still we continue with the next part, okay, on our next video. So kindly follow up for our discussion. Thank you.